Okay, so one of the things that you had to deal with last semester, especially when you solved quadratic equations, was this idea. Do you recall what the square root of a negative 1 is equal to? That's I. Square root of a negative 1 is equal to I. That's the definition that we gave the square root of a negative 1. If you put the square root of a negative 1 in your calculator, you get an error, right? So if you put the square root of negative 1 in your calculator, you get some kind of error, a syntax error, domain error, whatever your calculator says. Because you can't take the square root of a negative number. So remember, if I take the square root of 9, remember that means what number times itself is 9? 3. So square root of 9 is 3. But we saw last semester that the square root of a negative 9 is not 3, and it's not negative 3 either. Because what's 3 times 3? 9. Not negative 9. What's negative 3 times a negative 3? 9, not negative 9. So you can't take the square root of a negative number. That's where we get that imaginary number. That's where we get that I from. So the square root of a negative 1 is defined to be I. Now, if you recall last semester, what else we did was this. With this right here, this one, square root of negative 9. So remember we said this. We said the square root of a negative 9 is the same thing as saying the square root of a negative 1 times the square root of what? 9. What's the square root of negative 1? I. What's the square root of 9? 3. So this is 3I. So the square root of a negative 9 is what? 3I. So that's a quick review from last semester. We're still going to use those ideas here, but that was a quick review from last semester with the idea of imaginary number. Now, let's go back and review something from last semester. What is the square root of 3 squared? The square root of 3 squared, huh? It's 3. Because the square root of 3 squared means the square root of 3 times itself, right? The exponent tells you how many times you multiply by itself. So that's 3. Now you got to be careful with what I'm about to do with this one, though, with the negative number, though. But the square root of 3 is 3. What we saw last semester was this. If I have the square root of x squared, what's the square root of x squared? It's just x. The square and the square root undo each other. It's just x. So this right here is the square root of 3 squared, which is just 3. Now somebody might say this, well, can't you just say 3 times 3 is 9? Yes, you can, only because the 3's are positive. That's the only reason. And square root of 9 is 3. What you need to understand is this. The square root of, listen carefully to this, the square root of x times the square root of x is just x. The square root of x times the square root of x is x. So whatever x is, whatever number x is, whether it's negative or positive, if you multiply it by itself again, you're just going to say what? X. So listen carefully. You see this equation right here? It's an equation. I have an equal sign. I don't have a variable, but it's still considered an equation. If I square both sides, I get the square root of a negative 1 and I, right? I'm squaring both sides. What is the square root of a negative 1 squared? No, not 1. No. The square root of a negative 1 is I. What I asked you was, I said, what's the square root of a negative 1 squared? Say it again. Negative 1. In the square root of a negative 1 squared, isn't that the square root of a negative 1 times the square root of negative 1? And we just discussed the fact that the square root of x and the square root of x is just what? X is just your radicand. What's my radicand here? Negative 1. So the square root of a negative 1 times the square root of negative 1 is just what? So I'm going to ask you again. What is the square root of a negative 1 squared? Negative 1. And i's being what here? Squared. So what we know is this now. I squared is equal to what? Negative 1. That's what you need to know now. So whenever you see I squared, that's the same thing as what number? Negative 1. When you see the square root of a negative 1, that's the same thing as what number? I. Know these guys. Square root of a negative 1 is equal to what? I. I squared is equal to what? Negative 1. So these are the two things you have to know. Those two things will get you through this section. Knowing these two things will get you through this section. Knowing that I squared equals what? Negative 1. And that I equals what? Square root of a negative 1. Okay. Now, let's look at some examples. You remember last semester when you added and subtracted polynomials? So let's say you had x squared plus 2x minus 5 plus 3x squared plus 6x. When you added polynomials last semester, what did you do? How did you deal with this? How did you add these two polynomials last semester? You're adding them. You combine like terms. Combine like terms. So what is x squared and 3x squared? 4x squared. What is 2x plus 6x? 8x. And then there's only one constant, so what's the final part? Minus 5. So adding and subtracting polynomials works the same way as what we're about to do with complex numbers. All right, you're going to combine like terms. All right. Now, let's look at these examples. It's not difficult. Just listen carefully.
You always say that.
I do.
Always, right?
All right. Number 1. 2 plus 6i plus 3 minus I. 2 plus 6i plus 3 minus I. Now, let's do some context here. Let's talk about some context with this. Let's talk about what a complex number is. All right, a complex number. A complex number has this form. A plus bi. A complex number has that form. A plus bi. Okay? So is the first parenthesis a complex number? Yes. Is the second parenthesis a complex number? Yeah. It's of the form a plus bi. The a part is called the real part of this complex number. The bi is called the imaginary part. It's called the imaginary part because it has what in it? The I. It's very easy to remember. I, imaginary. I, imaginary. So in the first parentheses, what is the real part? 2. In the second parentheses, what is the real part? 3. Can I add 2 and 3? Yes. What is that? 5. In the first parentheses, what is the imaginary part? 6i. In the second parentheses, what is the imaginary part? Negative I. Can I combine those? Yes. What's 6i and a negative I? Plus 5i. So there's your answer. So all I did was with each of those complex numbers that were in parentheses, I combined their like terms. So the real parts are like terms and the imaginary parts are what? Like terms. Just like we did with the polynomials. You combine like terms. The directions will also say this. The directions will also say write the answer in standard form. Write the answer in standard form. Standard form just means a plus bi. So put the real, in other words, put the real part first and then put what next? The imaginary part. So don't write the answer as 5i plus 5 because that's not standard form. So the answer is not 5i plus 5 because I want it in standard form. So you got to say what first? The real part first, which is 5. Okay? Number 2. Four minus 3i minus, in parentheses, 2 plus 8i. 4 minus 3i minus 2 plus 8i. Now the first one is easy because the first one you're adding them. Here, what are you doing? Subtracting. So what might you want to do to make things a little bit more easier for you? Distribute the negative. Distribute the negative. So here you have, I'm going to leave in parentheses since I left the other in parentheses. Here you have 4 minus 3i, right? And remember, subtracting is the same thing as adding the what? The negative, adding the opposite, right? So if I distribute the negative, that becomes what? Negative 2 minus 8i. Right. So you remember one of the things you learned a couple of semesters ago, one of your courses a while back, not last semester, although you needed to know this from last semester, was you can change subtraction. What kind of problem? Addition, by adding the opposite. What's the opposite of a positive 2? Negative 2. What's the opposite of a positive 8i? Negative 8i, which is the same thing as distributing a negative 1. Now what's the answer, do you think? 2 what? Minus what? 11i, very good. So you're going to add your real parts together, and remember, put in standard form, so do the real parts first. What's 4 plus a negative 2? 2. What's a negative 3i and a negative 8i? Negative 11i. That's all you do. Okay, so I have this complex number. Number 3. Suppose you had 7i minus 2 plus 4i plus 6 minus 9i. So 7i minus 2 plus 4i plus 6 minus 9i. And it doesn't matter how you work these things. You could use a distributive property if you want to. In other words, you could get rid of the parentheses. I didn't get rid of the parentheses in number 2, but you could in number 3 if you want to. So you could have done that in number 2. In other words, here you're going to distribute the negative 1, right? So this becomes 7i what? Minus 2 minus 4i, and here you're really going to distribute what number?
1.
A 1. So you're going to be left with what? 6 minus 9i. So if you want to just get rid of the parentheses, that's fine. It's no big deal. No big deal at all. But then what you got to remember now is this. Since I want to put this in standard form, I've got to add the real parts first. So if you look at all these terms, what are your real parts? Negative 2 and 6. What do I get when I combine them? 4. What are your imaginary parts? How many imaginary parts do you see? 3. So it's 7i minus 4i. And what's 3i minus 9i? Negative 6i. So that's your answer. Okay? Number 4. 8i subtract a negative 3i. 8i subtract a negative 3i. So you see one like this in my math lab as well. Use the idea we talked about in number 2. This is easy to deal with if you think about number 2, when we discussed number 2. So that's why I discussed number 2 the way I did. Change the subtraction to what? Addition. You change subtraction to addition by saying add the what? Opposite. So 8i subtract a negative 3i means 8i plus what? 3i. And what's your answer? 11i. That's your answer. You're done. Okay? All right, any questions at this point? All right. Now, so what we did here was what operations on these complex numbers? What did we do to these complex numbers? We added and subtracted. What else can you do to numbers? Multiply and divide. Division is a little more complicated with these, so let's do multiplication first.
Show us how easy it is, though, aren't you?
All right, we're gonna multiply first. All right. All right. Now, at any point, did we use the idea of I squared? No. Not yet. But what is I squared equal to? Negative 1. So I have 5i times 2 plus 7i. Now, before we do that, let's kind of review something from last semester. Actually, it was from 98. That's when you dealt with with polynomials in Math 98. So in Math 98, remember when you had 2x times x squared plus 3x plus 5? What did you do here? No. You keep saying factoring. What did you actually do? Distribute. What's 2x times x squared? 2x cubed. When you multiply like bases, what do you do with your exponents? You add them. What's 2x times 3x? 6x squared. And what's 2x times 5? 10x. So basically, though, what you did was you used distributive property, correct? But you use also the fact that x times x is what? X squared. When you multiply like base, you do what to those exponents? You add them. What do I do here? What property do I use? Distributive property. What's 5i times 2? 10i. What's 5i times 7i? 35i squared. And that's where I'm at. Because remember, I times I is what? I squared. But you're not done, because you know what I squared equals to? Negative 1. So what I would do at this point is I would replace I squared with what? Negative 1. And what's a positive 35 times a negative 1? But the directions will say, write this in standard form. So that's not your answer. What's your answer?
Negative 35 plus 10.
Negative 35 plus 10. When we started the first hour, we used distributive property. So everything we've done, almost everything we've done, involved distributive property. All right, so when you do these, when you multiply these complex numbers, you're going to have to recall that I times I is what? I times I is what? I squared. You're going to replace with what? Negative 1. Okay. But yes, I squared is negative 1. All right, number 2. Oh, what's the answer? I'm sorry. The answer is what? Oh, no, okay, that is the answer. I'm sorry. I forgot that this is not standard form. This is what? Standard form. All right, so that's your answer. Number 2, negative 3i times negative 2 plus 8i. I want to multiply these two complex numbers. Negative 3i is a complex number. Negative 2 plus 8i is also a complex number. You multiply them, but the complex numbers on the outside is a monomial. So you can use what property? Distributive property. What is a negative 3i times a negative 2? Positive 6i. What is a negative 3i times a positive 8i? All right, so that's where I'm at. I actually write it as I squared. Now you're going to replace I squared with what? Negative 1. Because you know what I squared equals to. But what's the negative 24 times a negative 1? Positive 24. Do you all agree that's 6i plus 24? So what's your answer? There's your answer. Okay. All right, number 3. 6i times 2i minus 3. 6i times 2i minus 3. I will multiply those two complex numbers. What do I do first? Distribute. What's 6i times 2i? What's 6i times a negative 3? Okay. Am I done? No. What is it I've got to do? Replace I squared with negative 1. So that's 12 times negative 1 minus 18i. What's 12 times negative 1? Minus 18i. Is that standard form? Yes. That's a plus bi. What's your real part in the answer? What's the real part? Negative 12. What's the imaginary part? 18i. Okay. Is there any questions on that part? Okay. Now, let's kind of review something. So when I did this one here, when I did this right here, this review, to multiply these two polynomials, I had to use what property? Distributive property. To multiply these two polynomials, what did I use? The FOIL method. Remember the FOIL, F-O-I-L? First, outer, inner, last. Okay, use FOIL there. When you multiply two binomials, use FOIL. And a complex number is in what form? A binomial, a plus bi. So when we get to the next part of this complex number part, we're going to use FOIL. You're going to see what it looks like. All right, but let's kind of review FOIL. Remember, F stands for what word? First. You take the first term of each binomial. What's 3x times 2x? 6x squared. O stands for out. For what? Outer. Those are the outer terms. What's 3x times 3? Okay. I stands for what? What the inside terms? What's negative 1 times 2x? And L stands for last, the last terms of each binomial. What's negative 1 times 3? And then what'd you do next? Combine like terms. The on the inner, you were able to combine. So what's my answer? Minus 3. Okay. Now that takes us to multiplying two complex numbers that look like this now. So let's write this as number 4. 6 minus 2i times 2 plus 5i. 6 minus 2i times 2 plus 5i. I have a binomial times a binomial. What's the best way to multiply those two binomials? FOIL. So first, outer, inner, last. What's 6 times what? 2. What's 6 times 2? 12. That's your first. The first terms of each binomial. That's your first. The outer, what two terms would I multiply together to give you my outer? 5i, the terms on the outside. What's 6 times 5i? 30i. I stands for what? Inner, the inside terms. Which terms are the inside terms? Negative 2 and 2. What do I get? Negative 4i. And the L stands for the last terms of each binomial. What are the last terms of each binomial? Negative 2i and 5i. So what's negative 2i times 5i? Negative 10i squared. Now, a couple things here. You can combine like terms and you replace I squared with what? Negative 1. Let's do that first. Let's replace I squared with negative 1. All right. Now, all you got to do, remember, I'm going to kind of skip a step here, but all you got to do is remember this. I'm circling this right here. You see this? And I know that's equal to what number? Negative 1. All right, now listen carefully to this. So I have 12. I'm just going to rewrite everything else. 12 plus 30i minus 4i. And negative 10i squared becomes what? Positive 10. Because a negative 10 times a negative 1 is a what? Positive 10. And now what's the next step? Combine like terms. 12 I can combine with what? 10. What do I get? 22. 30i I can combine with negative 4i. What do I get? 26i. There's your answer. Okay? I'm going to do one more with this because that's on that second part of your in-class worksheet. So I'm going to do one more with the two binomials. So I only have time to do 2 of them. So here's number 5. Let's suppose we had negative 3 plus I times 7 plus 3i. Negative 3 plus I times 7 plus 3i. How are you going to multiply these two binomials? Oil. Okay. Negative 3 times 7 is 21. What two things are you going to multiply together? What two terms are you going to multiply together to get the outer? Positive 3i. What do I get when I multiply them? Negative 9i. What two terms are you going to multiply together to get the inner? What do you get? What two terms are you going to multiply together to get the last? I and 3i. What do I get when I multiply them? 3i squared. All right, now at this point, here's what I would do. I would circle the I squared and remind myself that's equal to what? Negative 1. Okay? So then here's what I get. I'm going to write all those 4 terms. See, you have 4 terms, right? We use FOIL, F-O-I-L, 4 terms. Negative 21 minus 9i plus 7i. And then 3i squared becomes what? Negative 3. Now combining like terms, put it in standard form. Put the real part first.
Negative 21 minus 3 is negative 24.
Negative 24. And what's a negative 9i and 7i?
Negative 2i.
There's your answer. Okay? All right. Now,